Let's look at some important properties of the Laplace transformation. The first property we want to look at is that what is the Laplace transformation of the derivative of a function? Okay. So if you simply put it as the regular definition, we have dft over dt e to the power negative st dt. In this case, we can use the simpler formulation of this integration by part, which is u dv dt dt becomes uv minus integration of dt. In this case, we consider this to be the part corresponding to dv dt and this part to be corresponding to u. So we'll have, or this will equal to, so u p, so u or e to the negative st, and v will be the, consider that this is dv over dt equals dft over dt, so the function itself evaluated between 0 and infinity, negative integration of du over dt, so u becoming this, will have negative s e to the minus st, and v is the function itself, so ft dt evaluated between 0 and infinity. Okay. Now if we evaluate this part, it will be, for negative infinity here, it will be 0. So 0 minus, for 0 this part becomes 1 and ft becomes f of 0. Okay. Now for this part, this negative becomes positive, s comes out. If you take this part now, it simply becomes 0 to infinity ft e to the power negative st dt. Now remember that if you consider this, if the Laplace transformation of the original function is written as fs, which is nothing but simply 0 to infinity ft e to the power negative st dt, which is exactly this part. Okay, so this one, now we get this equals dft over dt becomes, so if we consider this part first, so this becomes s, and this entire thing is simply fs, which is fs is nothing but the Laplace transformation of the original function. It will become fs, and this part remains minus f naught. So this is the one important property. The Laplace transform of the derivative of a function is expressed as the Laplace transformation of the function itself. So this is a very important property of this Laplace transformation. Okay. Now similarly, you can derive the Laplace transformation of this second order derivative of a function. So it will be s squared fs minus 0 minus f prime 0. Remember that f prime is simply, here will be referring to the derivative of the function at time 0. Okay. Now if you consider, for a simplified form, if you consider this f naught or d of f over dt at f naught, all of this term becomes 0. So we get, for an nth order derivative, will be simply become SNFS. And this is one of the very useful properties of Laplace transformation that we'll be using, because that will help us to convert the differential equation into algebraic equation. There are some other properties of Laplace transformation that you need to know. That Laplace transformation of, suppose you have the summation of two functions, so you have a1 f1t plus a2 f2t will be a1 f1s plus a2 f2s. Okay, so those are additive. However, f1t, if it's multiplied, f2t is not equal to f1s times f2s. So remember that this is not applicable. Or in the same way, Laplace transform of, suppose, y square t is not equal to y square s. So that these properties you need to remember. Okay. If this is the Laplace transform of the derivative, then what is the Laplace transformation of the integral then? So the Laplace transformation of integral of a function becomes fs over s. And now some other thing, there are two properties. What is called this final value theorem, which is very important for us in many cases. If you have limit t goes to infinity, the function is simply the limit s goes to 0. This is one important property that we'll be using. Okay, so in summary, some of the properties that are very important is that the Laplace transformation of this derivative of nth order equals to Sn and multiplied by the Laplace transformation of the original function. It has this additive property, a1 f1t plus a2 f2t. If we take the Laplace transform of the entire function, it will be a1 f1s plus a1 f2s. But you remember that this is not equal to f1s times f2s. Also, like Laplace transform of y squared t is not equal to y squared s. So if that's the derivative, what's the integral for this? Laplace transformation of the integral equals simply fs over s. The final value theorem again finally says that the value of the function at t equals infinity equals the value of the function of s equals 0, but the function is taken as s times fs.